Alright, so what I've been working on recently is trying to get things up to scratch with my NPCs and the AI, and specifically here today I'm going to show you my fixed NPC class, and that is basically a turret. Now, I just want to talk about AI for a bit. I said this in my last video. A lot of people confuse AI with mechanics. The way something moves is not AI. Pathfinding is not AI. AI is about decision making and basically what to do in certain situations. So, for example, the AI won't tell how the turret will move. What it'll do is it'll tell the turret to move, and the turret will move by itself. So in saying that, what I generally do when I design or create all my NPCs is I first design all the mechanics in isolation of the AI, make sure they all work, and then I add in AI on top of that. So that's what I've done. I've created my turret, and I'm going to show you all its mechanics, which the AI will use as a tool to manage its behaviors. So here's my little turret. It's called a pop top. It's a bit hidden away at the moment, so we're going to use its first mechanic, which is to deploy. What I've done is I've hard-coded the mechanics to the keyboard just for testing sake and for the sake of showing you in this video. So I'll press the key 1 and that will deploy the turret. I'll conceal the turret with key 2. You can see the little guns extend out and it pops up. So that's the first mechanic. Now the AI simply has to say to the turret deploy. So for example, I might have an area of effect trigger that will trigger the turret to deploy, and the AI will go, ooh, there's something in this area of effect trigger, I'm going to deploy, and it just tells the turret deploy. The turret does it. So that's the first effect. Now the next mechanic is the turn to angle. So the turret can turn to face any angle, and so I've hard-coded the key 3 to point 90 degrees to the right, and you can see after pressing the key 3 it points 90 degrees to the right. I've hard-coded the key 4 to point something like 200 and something degrees, and I'll press 3 again and go back to 90. So that's the turn to angle. It's not 100% useful except for when, so for example, it's not useful when you're trying to follow a character, but it is useful if you're trying to do something like the turret's looking left and right, looking for enemies. So the next mechanic after that is the spin mechanic. This is sort of like an idle state. Basically, with all these mechanics, I want the turret to be able to do the things that turrets are going to do a lot. So all of these sorts of things. So if I press 6, the turret will spin around in a clockwise direction continuously, and if I press 7, the turret will clockwise the other way. It's the same function, just with a different value passed. The value is 1 for clockwise and -1 for 7. So I'll just stop that. Now this is where it gets useful. In addition to the turn to angle function, I've created a turn to face position. So what I've hard-coded now is for the turret to turn and face the position that the character is currently at. So I'm going to press 5 for that, and the turret should look directly at my character, but this is just a single turn to face. This isn't tracking. There you go. You can see it always, every time I press it, it looks. Now this is where it gets really important. Obviously if the turret is shooting at something, it's going to need to track an object. Now what I've done is I've made it so that this sight box, anything that triggers this sight box will basically, the sight box will detect it's triggered. As you can see, it's detecting it's triggered, and it'll store a pointer to the object inside the trigger class, inside the sight box trigger class. Now the turrets can then go, the turret has a pointer to its sight box, and it can ask the sight box what is my closest target, and or what is my furthest target, a number of sort of things, and it'll get the pointer to my character, And now that it has a pointer to my character, it can figure out the position of my character every frame, and it can follow the character. So I'm just going to press 8, and the turret should follow the character wherever he goes. If I outrun it, he'll keep trying. So the turret's got track on now, so no matter where my character goes, the turret will follow. However, the turret won't go faster than its turret speed that is set in the object parameters. You can see I actually outran it the other way fast enough so that it actually decided it was quicker to change direction. So that's pretty cool. This is a lot of these turning movements are made easy thanks to Esenthel's extensive linear interpolation library, which I would missed a lot in Leadworks. So thanks for that, Esenthel. So that's the mechanics, and I'm just going to show you this in the editor. Just how powerful this turret class is and how it's broken up. Now, just before I go, you can see this turret has 2 Gatling guns. However, that's not a part of the class, the fact that it has 2 Gatling guns. With the exact same code I've written, those 2 Gatling guns can be lasers or regular guns, and they can behave completely differently. There can be just 1 gun, there could be no guns, there could be 3 guns, or there could be 50 guns. I can change all of these parameters based on the object parameters in the editor without changing any of the code. I can even change the look of this turret completely without changing any code. So that's the idea I've gone for, is really ultimate flexibility when I design these things, completely data driven, so that oh crap. Okay, so what you saw there was a bit of PhysX 3 playing up. I have a feeling PhysX 3 is got some issues still that need resolving, especially with the character controllers. Basically, something happened and it shot my character out to the side and out of the level, so hopefully that can be resolved later on. So what I was saying before was that I designed my these turrets and NPCs so that they are completely data driven, so that basically the initial setup code to make these classes is a lot more advanced and a lot more difficult and takes longer to do than if you were to do a fixed functionality turret. However, what it means in the long run is that I won't ever have to code a turret again, basically. There's maybe one other type of turret that I will code though, and that is a turret that allows tilting. I don't really want that for this turret because, as you can see, there's not going to be anything really flying around. Another thing I didn't show, which is actually part of that deploy and conceal functionality, was that the turret can actually go higher than it was. It can go about up to a 2nd story, and I'll just show you the model for the pop top. You can see it's a long corkscrew that drills into the ground, so that turret can actually go pretty high. So it actually has a move functionality as well, to move up and down a certain amount. That functionality is actually even more than that. It's actually able to move in any direction. Say for example a turret on rails, for example. So anyway, enough of that. Let's go and look first, see how this is working in the editor. It looks a bit different in the editor. I don't have the full turret here. All I've got is this ring, and that is just the base of my turret. The turret's made up of a bunch of parts. Now, I didn't want to do the mesh parts thing with this that Esenthel has, basically because I wanted to be able to chop and change these parts based on parameters I put in, well, the parameter window. So that's how that is. The base is the object class, and then I can load the other stuff separately. You'll also notice, and you already know if you watch some of my other blogs, is that the sightbox is a completely different object. It's not even connected in the editor to the turret at all. It's simply an object in itself placed near the turret. It has an ID. You can see here the ID of the sightbox, and this turret references that sightbox ID. So basically what happens is when it's loaded, when everything's loaded, the turret will go to the triggerverse, which is my trigger manager, and get that sightbox. And it will get a pointer to that sightbox so it can access its state, any objects that it's seeing, and it can change its matrix, of course, when the turret moves itself. So I thought that was pretty nice and flexible, because that means I can do anything I want with these sightboxes. I can scale them. I can. It doesn't even have to be a sightbox. It can be like an area of effect sphere. And the cool thing about this is that I can get non-programmers working on my game, and they can do a lot without even touching a piece of code. Because heck, I don't have enough time to do every single bit of every level in the game as well. So that's that. Now, I'll just show you a bit of the parameters for this. Actually, I changed my mind. Before I show you the parameters, you can see there's quite a lot of them. I'll show you how this all works out in the code structure for an NPC. Okay, so let's start from the top. We have my PopTub class. So this is the final derived class. And it inherits from the NPC fixed class. So I've made a class that basically all fixed NPCs will inherit from. So basically that's any NPC that does not use a character controller to move, even though like they actually can move up and down, etc. And anywhere. They don't use a character controller or a vehicle or something like that to move. And therefore they inherit from the game static object. And I've also made it inherit from my stateful objects class. If you don't know what that is, you can have a look in one of my previous blogs. Basically, it's an object that has a number of states and can be affected by other stateful objects, and it can affect other stateful objects itself. And so if we go into that, you'll see that a stateful object is actually just an extension of a finite state machine, and basically that's so that the turret can have states. And in this case, the states are the behaviors of the turret. So for example, the idle behavior, the attack behavior, the search behavior, those will all be states in this FSM. And so for example, how this would work is you would maybe unlock a door, and maybe that door has a relationship to the turret as a stateful object, because a gate is also a stateful object, as you can see here. Anything can be a stateful object as long as it has states of being. And then it will, if I set up the parameters, it can have a relationship with the turret to deploy and go in a search or attack. So like you unlock a door and it's like a trap, or you flick a switch that, you like, say you pick up an item and that activates like 100 turrets around you, for example. So that's the point of having these fixed NPCs as stateful objects as well. So I was talking to you before about the mechanics of a stateful of a NPC, how they aren't supposed to be part of the AI. I manage all my AIs within the behavior states in the FSM, so they are actually separate to the NPC itself. You can see I've got a container of behavior states, and whatever is the current behavior is the state that will manage the class. So I'll just show you, we have all of those basic mechanics that I showed you in the editor. Set turn to angle, set turn to face, set move, so that's move to a different position, set track an object, point it to an object, and set spin. You can cancel movement, you can cancel turning, and some other utility functions that you don't need to really worry about, except for set up sightbox. So you can get the sightbox and you can set it up so that it always stays in the relative position as it was placed in the editor, and of course update that, etc., etc. Now I'll just show you how easy it is for the AI to then make the turret do those things. And we'll have a look at, this is where I've hard-coded those keys to do those functionalities just for the testing. it's really simple. So for example, to deploy, keyboard 1, just set pop up. It'll do it automatically. That's actually a mechanic of a pop-top turret itself, not the fixed turret. Then I go set turn to angle, 90 degrees there. I just times it by pi on 180 to make it radians. Negative 125 degrees, set turn to angle. Simple as that. All the AI has to do is that. Doesn't have to even think about the movement code. Set turn to face, just puts in a vec position. Set spin, 1. So basically the turret can't spin faster than its maximum speed is specified in the parameters, but I can spin it slower and also, of course, in the negative direction. And then set track. All I need is a pointer to the object I want to track, and I just set track. So it's really, by doing these classes in this way, it makes the AI much easier, makes it much less clogged, the code for the AI. So for example, in the AI, it might be like, it might go, if the sightbox has seen an object, get that object and then track that object. Hope that makes sense. Now it gets a bit deeper than this. I also wanted to keep my gun barrels separate. They're actually a separate class. Now I don't know if I'm using so many classes that this is going to ruin performance, but it works, and I'm liking how it works so far. So I might have to optimize, well, I will always have to optimize a lot, but I've made the gun barrels separate, and this is so I can have multiple gun barrels. I can chop and change gun barrels, and you can see they've got their own mechanics: deploy, fire, start, fire, stop. So the guns themselves actually manage their own deployment. The turret will tell it to deploy, the guns to deploy, and the turret will tell it to fire, but it'll actually manage its own fire. It'll manage its own flare, muzzle flash. It'll actually shoot the bullets itself. You can see it has a damage variable, firing rate. This way I can do cool things like I can have a turret maybe with a big laser in the middle and 2 Gatling guns on the side, or I can have like rockets out the back of the turret and like a machine gun, 2 machine guns at the front, whatever I see fit. And because I'm able to chop and change all the model parts for these turrets, I'm able to make like a pop-top look right for each sort of scene. So maybe I have a scene where it's like a really clean lab, the pop-tops can look nice and clean. Maybe I have a scene where it's like an abandoned factory where all the pop-tops are like look raggedy and they got pieces of metal coming off them and stuff. So that's really the idea here, just ultimate diversity with data-driven design. So after that long-winded explanation, let's have a look at our parameters and how it works. So here's the pop-top and its parameters now. First, we'll forget all of these ones that start with barrel. Let's look at these ones now. So I'm able to specify a number of things. There's the name of the pop-top. Now this name is actually required for any stateful object. It's not actually a parameter for the pop-top itself, but because it's a stateful object, it needs a name, and that name needs to be unique. This num barrels is irrelevant. I'm going to delete it. I don't need that anymore. It's got a reference to its sightbox, so it can get the sightbox from the triggerverse. It's got its move speed, turn speed, a bunch of booleans, so it can start popped up, or maybe it doesn't move the sightbox, maybe it's a static AoE sightbox. And then it's got a bunch of elements, so the swivel material, the swivel mesh, the swivel is this red thing, all placeholder graphics, of course, like there's no textures on them yet. If you're wondering what this funny droopy ears are from they're bullet belts, but I haven't textured them. So, and the idea is that like I could just get the material from the mesh. However, what if I want the same mesh with a different material? I can slot that in there as well. And the core mesh, which is of course this one. Now you can see in those ones there's nothing about the barrels. Now you'll notice the barrels are indexed, so there's barrel damage 1, barrel damage 2. Well, what does that mean? Well, if you remember, there was 2 barrels for this turret, and yes, so that basically is it. There's a set of parameters that are required for each barrel, and if we go look here, this is the standard ones. It only comes with 1. There's barrel damage, how much damage the barrel does, the fire rate, the material of the barrel, the mesh of the barrel, the offset of the barrel to the swivel, and a secondary offset for deploying. Don't worry about that. The sounds that the barrel makes when it's warming up, warming down, firing. The type of barrel, now this is cool, the guns can be different things, so I can set if it's a laser type and it'll behave differently. So a revolve type is like a Gatling gun, it'll spin around when it shoots, recoiling type, etc, etc. One sec, I'll be back. So it's important to note that these are actually optional. I don't have to put any barrels in this thing, and some of them are even optional even if you do put them in. For example, the sound ones are optional, you don't have to have them. For example, if I got 2 Gatling guns, I don't want 2 sets of sound playing at the same time. It'll sound, of course, it'll be too much. It'll be extra processing, and secondarily, it will just be too loud. And I mean, imagine if I have 50 barrels firing, the sound will get ridiculous. So I only need 1. That's for number 1. See, it doesn't have any for 2. And basically, I can just add more barrels by just putting in the same parameters with high indexes, and of course different offsets, etc. I could so basically I could make another gun and give it a different mesh. That's a laser. I can change it to laser type. I can change its damage. So I think that's fairly diverse and useful. Now that I've talked and ranted for ages, let's actually make one now and see how we can make that a bit more diverse. So we'll get our base. It'll look the same because I don't have any new meshes. But let's change some stuff. So we're only going to put 1 gun on this, but let's make that gun in the center. So that's already centered, those offsets. Let's change its move speed, keep its move speed. Let's change its turn speed to be 2.5 times as fast. I think that is right. Yep, turn speed 1. This one will have turn speed of 2.5. Let's even be tricky and change its swivel material. Its core material to like a red material. It'll look horrible, but I'm just showing you. Oh wait, I've got to check that first. But I'm just showing you how it works, even though it look horrible. Yep, it's just 1 barrel. And now we need a bit more than that. We need to chuck in a sight box. So I've only got 1 sight box, but I can make many different shapes of them if I want. Let's move that into place. And let's make the sight box, let's scale it differently. Oops, that's not scale. X. So let's make it really wide and really short so we can see easily that it's different to the other one. We're going to set, so that's the ID of 1000. We'll have to set this one as 1001. We'll set the ID of this one's sight box to 1001. So that should link that turret to that sight box. And we also need to give it a unique name. So this one's pop top 1. Let's make this other one. No, not that. Guess copy paste doesn't work all the time. NEE underscore 02. Those are some things that you have to do, otherwise it won't work. So I've sort of got to write my own tutorial so I don't forget. And let's play it, and hopefully I haven't stuffed up anything. here we are. You can see we have 2 turrets now, and the different sightbox. Let's deploy them, of course, because it's because the turrets are hard-coded. They're both going to do exactly the same thing. Now you can see there's only one barrel coming out of this one, and it's in the center because we had a different offset. And you can see that its sightbox is following it. This one is exactly the same as before, and we can do all the same things. So that was turned to angle, turned to the 90 degrees angle. You can see that it turns much faster, like we specified. Let's do the spin, and spin the other way, and the best one, track. So I mean, I don't know why you would make a sightbox that's that fat, but just showing it works. One thing that didn't seem to work, and I'm not sure if it's because I didn't put the parameter in right. Oh, that thing happened again. I gotta figure something out for that. Is that the texture didn't change, but you know, little kinks will always happen. So anyway, I hope you liked that video. I hope it was informative. If it was, let me know. Maybe I'm an idiot, maybe I'm doing everything wrong, and if you tell me nicely, I won't get upset. So give me some feedback. You are free to use my ideas if you want, as long as you don't copy things exactly, like my art, for example. And I hope you enjoyed that, and I'll catch you all later. Hope to next time show you these guys working on their own without hard coding, with their own AI abilities, and I'll take it even a step further so that each turret has its own AI. In other words, they will behave completely differently. Again, all with the same code, just changing parameters. Thank you very much. See you later.